Now let's keep working on our car example. In the previous video, we created this particular function using Matlab actually created this function for us, create a rated horsepower MPG figure, and then we created this live script. It's called a car analysis main script, and inside of this main script we typed up some text, right, and then some equation, random equation basically, and then some Matlab codes. This kind of live script allows us to mix together different kinds of data formats, right? So text are written for people to read, and then these codes were written for Matlab to execute, and then Matlab also allows you to actually embed the figures that's created by using those codes into the document that you're actually writing. And if you want to adjust the font size inside of the live editor, you can hold down the control key and then press the plus button, and then it's going to increase the font size. And then if you want to reduce the font size, you can hold down the control key and use the minus button to reduce the font size. And then another thing that might be useful is that you have two buttons here, right? So show output inline. So for now, all the figures are kind of lined up on the right side of the script, right? But if you click on this button, and then all the figures are going to be embedded in the text that in the document that you're actually writing. So this might allow you to actually look at the figure in a more, which might actually make the figure bigger and easier to see. Right? But if you don't like this kind of format, you can still go back, and then all the outputs are going to be sort of on the right side of the screen. And if we go to the Live Editor tab, there's also ways for you to actually break up your documents into like multiple sections. Right? You have a section break. You have a section break. So suppose I put my cursor here. So I want to break down my the code into like two different sections. I can put my cursor here, and then if I click on this section break, then it's going to insert a break in here. Right, and now I have separated my code into like my document in like two different sections, right? If I want to create a new section, I can click on, put my cursor at the end of the previous section, and then click on section break again, and then it's going to start a new section, and then we can work on that new section, right? Another thing that I want to show you is how to use the G-scatter, right? So when we did this figure, we basically just adjusted the symbol size to like 10, and then the symbol is a circle, right? So there's a significant amount of overlap. So the cyan circle are kind of on top of the red circle, so it's kind of difficult to see the red circle, right? The red circle is supposed for the MPG rated horsepower relation for highway driving, for city driving, right? And then the highway driving ones, the circles that's in cyan color, is kind of on top of the red circle, so it's kind of difficult to see them. So one of the ways is probably just to change the symbol, right? If we want to use two different symbols, we don't really have to use just a circle, right? We can use a circle for maybe for the red ones, and then a plus for the highway driving, right? And then the color, for now we are actually giving it an empty string, so it's just going to use system default. But maybe we can actually change it to R and K. R means red, K means black. So for city it's still going to be red, but for highway it's going to turn into like black. And then maybe you can make the font size, make the symbol size, marker size smaller to like 5 or something. And then we can maybe re-execute the whole thing. Right, so now it looks like we can sort of see something, right? And then we can save it, right? We can save it. So that's our main script, how our main script actually looks like so far, right? So by separating the cars into like two different groups, city and highway, these two different groups, we were able to actually reduce the scattering quite significantly, right? So if you just look at these particular figures, there's no way you can sort of, the scattering is just too much, right? And now we have separated the group into like two different groups. One is called city, the other one is highway, right? But now let's write some codes. Let's write some codes. Right. This time we're going to try to create some codes by ourselves. The first thing that we are going to try to do is to actually select the data based on the city highway criteria, right? So how are we going to do that? So the first thing we're going to do is to actually create the index. So basically, if we look at the table, if we look at the variables if we look at the table, it's got lots of rows, right? For now, it's about 2,595 rows, right? And some of the rows correspond to city drive, right? Some of the rows correspond to highway drive, and some of the rows correspond to city drive. And it's not really particularly in a kind of a uniform pattern, right? So it's a highway, city, highway, city, highway, city, highway, city, highway, and then city, city, and highway, highway. So it doesn't really have a particular pattern, right? So how do we actually select all the rows that correspond to, say, highway, right? And how do we actually select all the rows that corresponds to city, right? So what we can do is to actually to use that particular column, that's car data. So the first thing we're going to do is to actually change car data 2007 to car data. It's actually later on, if we want to apply the same script to a different dataset, for example, the dataset for 2004, for example, right? Then we probably don't want to keep using car data 2007 as our variable name, right? Because it's going to be a different dataset, right? So if we want to sort of do this kind of replacement, let's just select it, and then we have a button here, right? Find and optionally replace text. It's Control F basically. So if I just hold down the Control key and press F, then it's going to allow me to find and replace car data 2007. So let's just replace it with car data, right? And replace all. Now if I go back to my main script, then all the occurrences of car data 2007 are going to become car data, right? If we want to run the whole thing, it should still produce exactly the same output, right? So the next thing we want to do is to make some selections based upon that city highway column, right? So city highway column is what? Car data dot city highway, right? Is that the header for that particular column, right? City underscore highway, right? So when this particular column equals to city, then I'm gonna assign this comparison. So this double equals to means comparison, right? It means comparison. It's basically comparing the values inside of this particular city highway column with the string city, right? And if this comparison turns out to be true, then the output for that particular row is going to be 1. Right? And if this evaluation turns out to be false, then the output for that row is going to be 0. And then we can assign the output to another vector that's called a city ID. Right? And then this comparison operator is going to do this kind of a comparison with city for every row of the city highway column, right? And then the output is going to be stored in city ID, right? And let's see what's going to be the effect of this calculation, right? This double equals to sign, it means a logical comparison, right? It's not the same thing as doing one assignment here. That's one equals I. One equals I means assignment. So basically, I'm assigning the output of this import data, car data function to this particular container that's called car data, to this particular name, car data, right? Here it's 2 equals I, which means comparison. Here I want to compare every element inside of the city highway column to city, right? And then it's going to do this comparison for every row inside of that particular column. If it turns out to be true, then it's going to return 1. And then if it turns out to be false, then it's going to return 0. So city ID is going to be a vector of 1s and 0s, right? And the 1s are going to correspond to the rows where the city highway equals to city. And the 0s are going to correspond to the rows where the city highway actually equals to highway, right? And then what we can do is to actually get the car data, or get the MPG data, for example, or rated horsepower data. So what we can do is rated HP city is going to equal to car data dot rated HP, and this time we're going to use city ID to index into it. Right, so city ID is a vector, right? But it's going to be a 1-0 vector, right? Some places it's going to be 1, and some places are going to be 0. So if we are using city ID to index into car data rated horsepower, so car data dot rated horsepower, this whole thing is just one column, right? And then parentheses, and then inside of the parentheses we are giving it another vector, and this vector is composed of just 1s and 0s, right? So what this whole thing is going to do is that it's going to select those rows corresponding to city ID equals to 1. So at those locations, at those rows where city ID is going to be 1, then that row is going to go into rated horsepower city. But if at that row city ID actually equals to 0, then that row is not going to be selected, right? That row is going to be left out. Only those rows corresponding to city ID equals to 1 is going to go into rated horsepower city, right? And let's just run this particular section of the code and make sure that it's correct, right? Run section. So if you right click on any place inside the section, then you're gonna have a choice that's called run section, and it corresponds to the key corresponding to the shortcut that's Control plus Enter, right? So if I hold down the Control key and press Enter, then it's gonna create something. It's gonna create something. It's gonna create a vector that's city ID, and then another vector that's rated horsepower city, right, inside of the workspace. And you can sort of see rated horsepower underscore city has only 1,299 rows, right? And the raw data, car data, is 2,595 rows, right? So it actually has selected a portion of the data, right? So if we wanna sort of apply the same thing to MPG, right? MPG, we can also select the MPG data. Let's go to city. It's gonna equal to car data dot MPG city ID, right? And then we can sort of create another ID that's called highway ID. Car data dot city highway equals to highway, right? And then rated HP highway is going to equal to car data dot rated HP highway ID, and then MPG highway equals to car data dot MPG highway, ID. Right. Hold down Control key and press Enter. It's going to execute this part of the script. Now we have MPG City and MPG Highway. Right, both inside of our workspace. Right, and then rated horsepower city and rated horsepower ID highway, and also inside of our workspace. Right, and if you want to add together the row numbers, right, it's supposed to be like 2,595. So 9 plus 6, that's 5. That's 8, 9, right, and then 4, 5, 2. So if you add those row numbers together, it's going to give you back 2,595. Right. So now let's try something else, right? So we have looked at how to make plots by using those buttons, but now let's look at the Apps tab. If we click on the Apps tab, we're going to see lots of buttons, lots of new buttons, right? We're going to have lots of new buttons. And depending upon the toolboxes that you have installed for your Matlab or purchased for your Matlab, you might see different number of buttons and different kinds of buttons, right? And then if you have a show more, the down arrow here, the inverted triangle here. If you click on it, you're going to be able to see more of those buttons, right? But now let's click on the distribution filter. So the distribution filter is going to open a toolbox that allows us to fit distributions, right? Fit histograms with some kind of a distribution, right? With certain parameters, right? And this particular tool is gonna give us some menu items. So data, right? Import data. This toolbox is gonna allow us to modify import data. If we click on data, then we can select data from the workspace. So import workspace vectors. Let's select MPG city, say, right? And sensoring none, frequency none, dataset name. Let's just call it MPG city, right? City data. Let's get rid of the data. Let's just call it MPG city. Right? And then after we're done with the selection, we can click on create dataset. Then underneath it, we're going to be able to see MPG city. Right. So what's being plotted in the background is the histogram of MPG city. So we have like 2,595 rows, right? 2,595 cars basically, and then we're plotting the MPG. So the horizontal axis is going to be MPG mile per gallon, and then the vertical axis is sort of the proportion, the fraction of the cars with a particular MPG. Right, suppose I look at the MPG equals to say 30, right? That's 30. So the proportion of the cars with the MPG value of 30 is going to be about 0.01, right? That's about 1%. So 1% of all the cars in this particular data group. This data group is the MPG city, right? So that's all the city drives. For all the city drives, among the 2,595, no, it's not 2,500. It's 1,200 something, right? So 1,200 something those cars, about 1% of it has a MPG of 30, right? Okay, so that's one data set, right? Now let's import another data set. That's MPG highway. Right, and let's change the dataset name, and then click on create dataset again. And now we're gonna see a different histogram, right? That's for these green bars. These green bars are for the MPGs that's on the highway MPGs, and you can sort of see it's actually two different populations, right? Two different groups, and their distribution actually looks very, very different, right? And at this point, we have imported the dataset we want to fit. So the distribution fit toolbox is going to allow us to fit those histograms with a specific distribution. Once we have finished importing the data, we can close this dialog box. And then let's click on new fit. New fit. Right. Fit name. Fit name. Let's change the fit name to MPG city fit. Right. And then the data we're going to use is MPG city. And then the distribution. What kind of distribution we want to use to fit this particular histogram? Right. The default value is normal distribution. It's going to fit a Gauss into it. Right. But we can choose different kinds of distributions. For example, do we have a log normal? Log normal, right? Log normal. Let's use log normal and give it a try. Let's see how it's going to work out. Apply. We click on apply button, and then it's going to compute a fit to those histograms, right? And looks like it's quite acceptable to me, right? But depending upon your application, you could sort of choose different kinds of fit, right? So now we have one fit. We have one fit, right? And let's try to create another fit. But let's look at, before we create another fit, let's look at the fits in our manage fits. Let's close this window first, and then let's look at the manage fits. Right, inside the manage fits, we already have the MPG city fit that we just created. This red curve here, right? And it's telling us it's log normal. The data set used is MPG underscore city, right? And the name of the fit is called MPG city fit. That's the red curve here, right? And then let's create another fit, new fit, right? This time it's not MPG city anymore. The data is going to be MPG highway, and then let's call it MPG. Let's call the fit MPG highway fit, right? Again, let's use log normal. And then let's just apply. So now we're going to see another log normal plot. That's the blue curve to the fit, right? So now we have actually did some distribution fitting to the two different populations of MPG in our dataset, right? And at this point, if we want to reuse the entire process for a different dataset, we can click on the file menu button and then generate code. And now it's gonna give us another function that's called create a fit, right? And then it's gonna have two outputs. That's probability density 1 and probability density 2. The input that it expects is MPG underscore city and MPG underscore highway, right? And the function is slightly longer, right? It's kind of slightly longer than all the functions that we have seen before. And for now, the code probably won't make too much sense to us, but we have seen some of the code, right? X label, Y label, this kind of function calls. It's basically creating a new figure and then making, and then plotting into those figures. So now let's change the function name. Let's change it to make it better, right? MPG fit. Create MPG fit. And then let's save it. Go to the edit tab and then save it. Create MPG fit, save it. Right. And then we can actually go back to our main analysis script and then call this particular function, right? Let's just so this function is going to create two outputs, right? But let's just neglect those outputs for now, and just call the function create MPG fit, and the input it expects is MPG city and then MPG highway, right? We have created these two. Vectors, right? MPG city is here, and then MPG highway is here, right? And all we have to do is to give this particular function these two inputs, right? And then hold down the control key, press enter. Then it should be able to produce all the figure, the distribution fits. That's the figure that this piece of code just created. If we want to look at a bigger figure, right? So the histograms, the columns, are actually from the data, and then the red and blue curves are actually the fits, right? And so now we have created the main script, two functions, right? Create mpg fit.m, that's just the distribution fit code that's automatically created by Matlab, and then create rated horsepower mpg figure, that's this particular figure, right? And then we also used a gscatter to make another figure by ourselves instead of sort of using Matlab automatically generated codes to do the plotting, right? And we can sort of make the analysis even more complicated, right? We can sort of subset the data even further. For example, select the data not just based upon city highway, but also based upon if it's a car or a truck, right? In the data table, we also have another column that's called car truck, right? So we can also select this data based upon car truck, if it's a car or if it's a truck, and then we can also apply distribution fitting on that kind of data, right? On that kind of selected data. Right. So, but it may not be very interesting, right? So the only thing that might be new is to how to actually come up with the index. How to actually come up with the index, right? That's probably the only thing that's new, right? Maybe let's just try to do that. Let's insert a section break first, right? And then let's try to see what's actually going to be the syntax for selecting data based upon not just the city highway but also car and truck. So we have two conditions, right? So car data city highway must equal to city, and car data dot car truck must equal to car. So let's do car city ID is going to equal to car data dot city highway equals to city, right? And then the second condition is what? The second condition is that the car city, this particular column, the car truck column must equal to car, right? If we want to select the car in city, right? And so this is ampersand, or we can also use the Matlab keyword and, right? But let's just use the ampersand. Ampersand means that both conditions has to be true in order to actually output a 1, right? So car data dot car truck compared to car, right? So car city ID means that this is the ID for all the cars that's driving in city, right? So if we want all the cars that's driving on highway, we can pretty much just duplicate this piece of code. Oh, I've done something wrong, I think. Control C and then Control V. So car city ID, car highway ID. So this is not city anymore, it's highway. Right. And then we can pretty much do the same thing for trucks. Right. So this is a car on city and a car on highway. And then we have the same kind of selection for trucks. Control C and then Control V. Truck city ID, truck highway ID. Right. So now we have to change this part of the code. Truck right. And again, we can run this particular section. just Control Enter. Then we're gonna create more variables in our workspace, right? So you have car city ID, car highway ID, and then truck city ID, highway ID, right? And then you can even you can create the MPG and rated horsepower based upon using those IDs, right? So suppose we want to do MPG. So MPG car city is gonna equal to car data dot MPG, right? And then car city ID, right? And then MPG car highway is gonna equal to car data dot MPG car highway ID, right? And then MPG truck city is gonna equal to car data dot MPG truck city ID, and then MPG truck highway is gonna equal to car data dot G truck highway ID. It's not IDX, it's ID, right? Highway ID. And again, we can run this particular part of the script to Control Enter, right? So for MPG truck, we have city or highway, right? So it's 627 plus 625. 627 plus 625. That's 1252. 1252. So that should equal to what? 1252. And then, oh, I see. What I'm supposed to do is to add up these two rows, right? Then we get all the MPG city, right? Truck city and car city. So 672 plus 627. 627 plus 672. That's 1299. That should be the same length as MPG city. That's 1299, right? So it looks like our selection or our filtering of the data is done correctly, right? And then we can again run the distribution tool. We can run the distribution tool with 4 data sets, for example, right? Let's just give it a try. Distribution with our distribution filter, right? That's our distribution filter. Let's maybe let's delete some of the delete it, and then delete it. Let's delete those 2 fits, and then close it, and then data. Let's delete those 2 data. Delete these 2 data, and instead we're gonna import so car city, right? Create data sets, and then car highway. Create data sets, and then truck city. Create data sets, and then truck highway. Close. So now we have like 4 different data sets. So we have like 4 different histograms, right? And then we can just create fits. Car city, let's call it MPG car city fit, right? And then we can apply. For now, it's like a normal distribution, right? Let's change it to log normal. Log normal, and then apply again. So let's look at it, right? So it's trying to fit the fit the bars with the purple color, right? But it's kind of hard to see the purple colored bars. And then yeah, I think that's good enough. Let's try to create another fit. Car city, car highway, right? Let's call it MPG car highway fit. Again, let's change it to log normal. So that's car city and the car highway. New fit, and then this time truck city. And then let's also create one for truck highway. Right, so now we have like 4 different fits for 4 different datasets. Right. And again, we can try to generate the codes for that. Let's generate code. Right, so now it's got like 4 different outputs and then 4 different inputs. Right. Let's change the file name mpg mpg city highway car truck fit. Right, and then maybe it's a very long name, but nevertheless, let's just save it. Right, and then back in our main script, we can call this particular function. Right, so again, we can just forget about the output and just call the function itself. Create mpg city highway car truck, and then the inputs it's expecting mpg car city, car highway, truck city, and truck highway, and we have all those inputs. That's mpg car city, mpg car highway, mpg truck city, mpg truck highway. Right, so now let's just execute this part of the code again. It's saying create mpg oh, I missed the fit. There's a fit here. Again, let me just right. Yeah, so now it's got the 4 different fits. Right, so that's all the scripts and all the functions that we are gonna be using for exercise 1. So for exercise 1, you're gonna have how many codes? 1 main script, right? 1 main script, that's a live script, MLX live script, and then 1, 2, 3, 4 functions. 1 function for importing the data, 1 function for making plotting the rated horsepower MPG, 1 function for making the MPG fit distribution fit, and then 1 function for separating the MPG into like 4 different groups and fit make a distribution fit for each one of them, right? So that's 5 codes. That's 5 codes.